Okay, so now the question is, who's going to get to this fire faster? We know Ranger Rick is exactly 8.31 miles away from the fire. Tracy is about 11.55 miles from the fire, but they have Jeeps that travel at different rates. Ranger Rick has a Jeep that could go 20 miles an hour. Tracy is 27 miles an hour. But realize when you're comparing two units, miles and hours, you were talking about a rate. Just like law of sines is a rate, sine of 80 divided by 13. So this is a trig function to compare to feet. That's a rate. You're comparing two units. So I know Rick's Jeep is this rate. Is there another rate I can set it equal to? Yeah, I know that he needs to travel 8.31 miles, but I don't know the time. So now I've got a rate that equals a rate that's a proportion. So I can cross multiply again. X times 20 equals 1 times 8.3. Divide both sides by 20. And I discover that it will take Rick 0.42 hours. Remember, X was in hours. So it'll take him 0.42 hours. Nobody really communicates like that. We want to convert that to minutes. So how many minutes is 0.42 hours? Well, that's another rate. There are 60 minutes in 1 hour. So I would multiply by 60 and get about 25 minutes. It's going to take Rick about 25 minutes to travel 8.31 miles to arrive to this fire. What about Tracy? Tracy has longer to go, but she has a faster Jeep. So I compare these two rates, I solve, and I discover it's going to take her 0.43 hours, just a little bit more. I multiply that by 60, and I discover it's 26 minutes. So Rick is closer. Even though he has a slower Jeep, he will still get there faster than Tracy, but only by 1 minute. Last problem. How far is Cassius from Caesar? Again, you've got an angle, side, angle situation. So the first thing I'm going to do is figure out that third angle, and that's just a matter of subtracting from 180 degrees for that whole triangle, minus 33, minus 49, and I get 98 degrees. So I want to find this distance. How far is Cassius from Caesar? And I don't have a right triangle, so forget any idea about SOHCAHTOA or Pythagorean theorem. I should point out that this was meant to be here. I do mean to have this. That is a right triangle. But how do I set up to find C? Well, again, law of sines. I want to connect any opposing relationships. I've got 98 degrees, and I've got its opposite side, 20. So that is I'm going to use that ratio. I want to find this, so I'm going to take its opposite angle, which is 33 degrees. So when I set those two ratios together, I get this. Two ratios that equal each other is a proportion. So now I can cross multiply, I get that, and I discover that Cassius is about 11 feet from his nemesis, Mr. Caesar. Two more questions, and then we're done. How far is Brutus from Mark Antony, and how far is Mark Antony from Caesar? We're going to do Mark Antony first. How far is Mark Antony from Caesar? Let me erase this because I want to find this thing right here. And there are a few ways to solve this, but I want you to realize that you can use this right triangle. As soon as you have a right triangle, you have a huge advantage. You can use SOHCAHTOA. You can also use a squared plus b squared equals c squared. So how can I use SOHCAHTOA to find this x value over here? Well, what do I have? I have 11, which is the hypotenuse of that triangle. And since I have the hypotenuse, I'm probably not going to use tangent. It's either sine or cosine. And I have one angle measure, 49, and x is the opposite side of 49 degrees. So that tells me sine. The sine of 49 degrees is the opposite side of 49 in a right triangle, which is x, divided by the hypotenuse, which is 11, multiply both sides by 11. And let me pause right here. Juniors out there, juniors, you're taking the SAT this year. There is a non-calculator portion of the SAT, and I would bet my next paycheck that there's a SOHCAHTOA problem. My next paycheck, and if I'm wrong, you come find me. But there's also, remember, there's a non-calculator portion. So this is the answer. This is as far as you can get without a calculator. That's pretty far. How far is Mark Antony from Caesar? He is exactly 11 times the sine of 49 away. Now, when you have a calculator, you would just take 11 times the sine of 49 and discover that he is about 8.3 feet away. Mark Antony is about 8.3. Last question. How far is Brutus from Mark Antony? So we'll call that W. How far is Brutus from Mark Antony? You could do law of sines because you've got 33 degrees and its opposite side, 8.3, or you could use the big triangle and use 11 as the opposite side. There's lots of ways to solve this one, but we want to choose the laziest. We want to have the least amount of work. You know, we're all alike. We want to do the least amount of work to get the same results. So if you focus on this right triangle, you could do SOHCAHTOA as long as you stay within that green triangle. You can also do law of sines because law of sines works for right triangles as well. But what function, how can I solve for W the fastest? And I hope you realize that you could use tangent. The tangent of 33 degrees is what ratio? What over what? It's opposite over adjacent. The opposite side of 33 degrees is 8.3. The adjacent is W. If some of you are thinking, isn't 11 the opposite of 33 degrees? That's true. That's true of the big triangle. But if you're talking about the big triangle, it's not a right triangle, so you're not using SOHCAHTOA. We are just focusing on the green triangle, and the opposite side of 33 degrees would be 8.3. The adjacent side is W. Multiply both sides by W. Divide by tangent. And what do I discover? How far is Brutus from Mark Antony? 8.3 divided by tangent of 33. And that is about 12.8 feet.